The HEOS project, funded by the Swedish government, is searching for signs of Dyson spheres in space. This initiative operates under the belief that such extraterrestrial power plants not only exist, but can also be detected. Dyson spheres are massive energy-harnessing structures built by advanced civilizations to capture and utilize the power of stars. The key question remains: could HEOS soon enable humanity to make first contact with an alien species? Imagine astronomers discovering unusual structures in distant star photographs, which provide clear evidence of Dyson spheres. If these megastructures exist, they are no longer a mere theoretical concept, but a probable reality within our universe. These advanced civilizations do not rely on fossil fuels or nuclear power. Instead, they tap into the energy of entire stars or even galaxies to sustain their technological needs. HEOS is Sweden's first initiative to search for techno-signatures, named after Hephaestus, the Greek god of blacksmithing. The project aims to identify possible traces of extraterrestrial engineering on an astronomical scale, particularly focusing on Dyson spheres. The very existence of this research underscores the growing belief in extraterrestrial life and the increasing effort to establish contact with other intelligent species. Dyson spheres can only be constructed by civilizations classified as Type 2 or 3 on the Kardashev scale, far surpassing humanity, which has yet to reach even Type 1. If we were to discover such civilizations, they could potentially aid us in solving our technological challenges and advancing to a higher level of development. According to U.S. researcher Laura Mersini-Houghton, thousands of intelligent civilizations may exist in the universe, but we have yet to detect them due to our isolated location in the cosmos. The statistical probability of other life forms is high, with at least 36 intelligent civilizations estimated to exist within the Milky Way alone. Given the immense scale of the known universe, the number of highly developed species could be in the thousands. The HEOS project has yielded promising results, analyzing data from over 5 million stars and identifying 7 potential candidates. These stars, primarily red dwarfs, exhibit strong infrared emissions that align with theoretical models of Dyson spheres. While traditional SETI efforts focused on detecting radio waves, modern approaches prioritize infrared telescopes. Since a Dyson sphere would partially block a star's visible light and re-emit absorbed energy as heat, it could be identified by excess infrared radiation. If natural causes like dust clouds can be ruled out, such infrared sources may indicate an advanced civilization. Over the past decade, HEOS researchers have utilized data from the Wide-Field Infrared Survey Explorer, WISE, the Gaia telescope, and TESS to search for evidence of megastructures. The 5 main types of Dyson spheres. Dyson spheres theoretically allow civilizations to capture and utilize the entirety of a star's radiation, opening vast possibilities for technological advancements, such as powering entire space settlements. There are 5 major types of Dyson sphere structures. Dyson shell. The classic concept involves a massive, hollow sphere entirely enclosing a star to capture all of its energy. The star's radiation is absorbed by kilometer-long solar cells lining the shell. However, such a structure would be highly unstable and susceptible to catastrophic failure due to gravitational imbalances or asteroid collisions. Constructing a Dyson shell would require immense resources, potentially requiring the dismantling of entire planets. Dyson swarm. Instead of a solid shell, this concept consists of millions or billions of individual solar satellites orbiting the star. These satellites collect solar energy and transmit it via microwaves or lasers to receiving stations. This modular approach allows for gradual construction, but it demands a highly advanced control system to prevent collisions. Dyson bubble, a variation where lightweight, reflective solar panels are suspended in space using the star's radiation pressure. These mirrors direct sunlight to collection stations and provide energy without requiring heavy support structures. However, keeping the mirrors stable requires exceptional precision, likely involving advanced nanotechnology. Dyson ring, a simpler version of a Dyson sphere, where a massive ring orbits a star, capturing energy through solar panels. The energy is then transmitted wirelessly. Constructing a Dyson ring requires advanced stabilization techniques and access to asteroid mining for building materials. This design could serve as an entry-level step toward more complex Dyson structures. Dyson network, a dynamic combination of multiple Dyson structures, such as swarms, bubbles, and rings. This decentralized approach allows for gradual expansion, adapting to a civilization's energy needs over time. The irregular arrangement of components in a Dyson network results in complex light fluctuations, making it relatively easy for researchers to detect. When can humanity build a Dyson sphere? Currently, humanity is nowhere near constructing a Dyson sphere. The Parker Solar Probe, the fastest spacecraft ever built, took 3.5 years just to reach the Sun's vicinity and still struggles with the Sun's gravity and harsh conditions. Our species has yet to set foot on another planet, and the last human mission to the Moon occurred over 45 years ago. Transporting materials close to a star for construction is an unimaginable challenge given our present technological limitations. Compared to civilizations capable of building Dyson spheres, humanity is technologically primitive. Achieving such a feat would require advancements in space travel, materials science, and energy transmission. A Type 2 civilization on the Kardashev scale would need to possess supercomputers, nanotechnology, AI-driven construction, and efficient superconducting energy transfer systems, technologies that remain theoretical for us today. Despite these challenges, the HEOS project is taking humanity's first steps toward uncovering evidence of advanced extraterrestrial civilizations. As our technology improves, the possibility of detecting and understanding Dyson spheres and the civilizations that build them becomes ever more tangible.